Welcome to your next module. And so in this module, we're going to learn about planetary geology. So certainly we've discussed a lot of information about geology here on planet Earth, but there are other planets and objects in our solar system that we can use the knowledge that we've learned about the Earth to understand some of these objects. So certainly the terrestrial planets, Mercury, Venus, Mars, those are what are called terrestrial. They're kind of rocky, kind of like Earth. And then we have the gas giants that are beyond that, Jupiter, Saturn, Uranus, Neptune, all that good stuff. Even Pluto, although, now it's been downgraded. But we want to look at those objects and understand something about them. So certainly we can send lots of satellites and rovers and all those things, and we have. But we want to understand what's going on. How do we do that without being there? Well, imagery plays a big role. And so there's some visual cues that we get from Earth, and we see some of those same features on, let's say, Mars. We might then interpret that some of the processes that happened on Mars are the same that happened on Earth, and that can help us understand what's going on there. Certainly we can sample the soils and do that kind of good stuff and use that knowledge to understand how Mars formed and how it developed over time. So that's kind of why we understand that. We want to understand that. And of course, lately, we want to go back to the moon. We want to understand what's going on there. Asteroids and objects that are floating around that are left over from the formation of our solar system might be valuable. We're talking about going there and harvesting, the mineral content and all that crazy stuff. So it's good to understand something about the geology of our solar system. So with that being said, we're going to look at that here in this first part, and what I'm going to do is have you basically just kind of click these links. They'll take you to the NASA page, which is where most of this information is held. So how we're going to do this is there's no time limit on this quiz like normal because there's a lot of info here. So you can kind of treat it like a homework assignment where you can open the quiz and kind of look at the questions and then go through and click these and read through the information to find the answers. But this way you'll kind of get, a little bit of info about all of the planets. So the first link is just an overview of our solar system. And then of course some information about the sun. And then the planets, even including Pluto, even though I know it's not a planet, we're still going to learn a little bit about Pluto because we have some information now about Pluto. So that's how you'll do the main lecture quiz. You can just kind of go through that info. This is just a visual to show you all the objects that have been identified, objects usually meaning asteroids. These are small, hunks of leftover remains from our formation of our solar system that didn't basically congeal into planets. And so those objects have been identified, and you can just kind of get a quick view of where they are and how many there are. It's just like a minute video or something like that. So you can go ahead and look at that also. That's what you'll do for the main lecture quiz. And then we, of course, have an article that talks about the volcanoes that are actually in our solar system. So the same thing, understanding Earth's volcanoes help us understand volcanoes that are in other systems, other planets, right? So you can go ahead and read that before you take the article quiz. And then finally, I'm going to have you look at this little program that was developed by Purdue University. And all it is if you click on it, it'll take you, let's see, I got it here. Basically, it's an impact. So we know that there's been impacts, asteroid impacts in the geologic past. We know in the future there'll be one. And so, the dinosaurs were affected by a large impact. And so here what we can do is we can input some information and then get some results out. So distance from, how far are you from where the impact happened, and some parameters of the object itself. And then you can hit calculate, and it'll give you, what is the fireball like? What is it hitting water? How big was the tsunami? And all that kind of good stuff. So you can get an idea of how big an object needs to be to do some major damage. Do small objects have the capacity to do a lot of damage even though they're small? Maybe other factors come into play, what they're made of, their velocity, their angle. And so basically here in the homework, I'm going to give you some parameters to input, and then you can look at those and kind of give me what was the output, and then maybe do some things on your own. So this is just related to this link here, which is talking about the impact. So You go ahead and do that for the homework. And finally, you do have a lab. Yes, one more lab, just like all the others in format. And it's just going to be an overview of all the other labs we've had over the semester. So just a review to go back and look at some things. So you can go through that. Remember, of course, you can take the lab multiple times. And at this point, it looks like it's all working. So you can just put your name in the email box and send it on its way. And hopefully I'll get the score and everything will be good. All right, so also remember there's no final in this course. So after you've completed all the assignments in this last module, you are done for the semester. And so that'll be good, and you can access this a little early. All right, so if you have any questions, as always, comments, concerns about content or anything else, please don't hesitate to contact me.